All right, so today we're going to start looking at normal distribution, which is our third type of distribution for this unit. And we're just going to kind of just do a little piece of it today, and then we'll keep going next class. But a couple things we want to talk about today. So if you remember our normal distribution, we talked about this in Unit 1 and Unit 2 when we were talking about what kind of shape a curve makes. Right, so when we talked about being a bell shape or symmetric curve, this is what we would call a normal distribution. So our mean is that value that goes in the middle, that mu value, and about half of our data lies on each side of that. And so what can be important to this is if we need information, if we're looking for values that we want to compare things that have different means and different standard deviations, we can actually put them on the same normal curve. It's called our standard normal curve by turning it into a z-score. So what we're essentially doing is we had two normal curves that were different, and we can put that information on the same curve by calculating the z-score. The z-score tells us how many standard deviations we are away from the mean. So if we're above the mean, we're a positive number. If we're below the mean, we're a negative number. So how to calculate a z-score? You take your x value, you subtract it from the mean, and divide it from the standard deviation. So for example, if I want to find the mean or the z-score here, I'm going to take my x value, 76, subtract it from my mean, and then divide it by the standard deviation. So when I do that, I would take 76 minus 81.7 and then divide it by 3.1. And that would tell me that my z-score is negative 1.84. So if we were to look at that on a standard normal curve, and we'll talk more about what standard normal looks like next class, but the mean is 0. Your standard deviation is 1. So then a score of negative 1.84 would be roughly over here. So that's where it would fall on your curve. So for number 2, the same thing. If I want to find my z-score, I take my x value, subtract it from the mean, and divide it by the standard deviation. So I would do 110 minus 106, and then divide by 9.8. So I end up with 0.41. So if we looked at a standard normal curve, that value would be right about there. So this value, right, if you're kind of comparing the two to each other, this value is closer to the mean than this value is. And that's kind of the good thing about z-scores, is that we can take values that don't have the same mean or standard deviation or don't have the same data, and we can actually figure out, we can compare them to each other by putting them on the same standard normal curve. So for instance, if we look at number 3 on our paper, so it says, which score is in a better position? A test score of 78 in a class with a mean of 73 and a standard deviation of 3, or a test score of 130 in a class of 115 and a standard deviation of 10. So again, these have different means and standard deviations, so they're pretty difficult to compare who did better. So what we can do is find their z-score. It'll put it on the same normal curve, and then we can compare them. So if I look at the first one, I have a test score of 78. The mean is 73 and the standard deviation is 3. So to find my z-score, I would take 78 minus 73 divided by 3. So when I do that, I get 1.6 repeating. So if we think about our standard normal curve, just like we made above, our mean is 0, our standard deviation is 1. So a 1.6 would put us right about here. All right, so then let's look at our other test. So this person got a 130 when their mean was 115 and their standard deviation was 10. So I have 130 minus 115 divided by 10. So their z-score is 1.5. So that would be closer to 1, somewhere like there. So then if we think about the context of this problem, the mean is the mean test score. So the farther you are away from the mean this way, the better you did, the more negative. The farther you are this way, the worse you did. So the purple test, this person actually scored better because their value is farther from the mean in the positive direction. They did better on the test than the average. So that's really where z-scores can come into play and help us. All right, so what we're then going to be able to do with z-scores, or really any data for this matter, is we can find the probability of something happening by looking at how many standard deviations they are away from the mean. Talking about what's the likelihood based off of where its location is to the mean. So we have what's called the empirical rule. And the empirical rule tells us that if we're within 1 standard deviation from the mean, if we're within 1 standard deviation of the mean, 68% of our data lives within 1 standard deviation of the mean. So that means overall 68% of the time we're falling within 1 standard deviation of the mean. 95% of our data is within 2 standard deviations of the mean. And then 99.7 is within 3 standard deviations. So these numbers are going to be very important for us to remember. We're going to need to know these 3 values. That 68 is 1 standard deviation, 95 is 2 standard deviations, and 99.7 is 3 standard deviations. And then what that can help us do is figure out probabilities based on these empirical rules. So we'll look at some examples on the back of our paper. So if we go ahead and flip our paper over, the distribution of 75 adult males is approximately normal with a mean of 165 pounds and a standard deviation of 25 pounds. So based off of this, we know that our mean is 165, so that goes in the middle. And then with the standard deviation of 25, that means I'm going to add 25 going this way, and I'm going to subtract 25 going this way. So if I add 25, 165 plus 25 would give me 190. So I add 25 and I get 190. I add 25 again, I get 215. I add 25 again, I get 240. I'm going to go the other way by subtracting 25. So if I subtract 25, I end up with 140. Subtract 25, I end up with 115. Subtract 25, I end up with 90. So going this way, right, I'm just adding my standard deviation. Going this way, I'm subtracting my standard deviation. So I'm subtracting 25 every time. So we can figure out kind of by our empirical rule that we just talked about on the last page, by our empirical rule, what percentage of people fall within, the percentage of people that fall within these weight amounts. So for instance, the first question asks us, what percent of weights are between 90 and 240? So remember, these two are 1 standard deviation away from the mean, right? I went 1 this way and 1 this way. So by our empirical rule, 1 standard deviation is 68%. Then these two, this one and this one, are 2 standard deviations away, right? I went 2. So then by my empirical rule, this is 95%. And then these two are 3 standard deviations away. So by my empirical rule, I'm at 99.7%. So the first one asks between 90 and 240. Our empirical rule tells us that's 99.7%. So 99.7% of all the weight of men are between 90 and 240. So then it asks what percent is between 115 and 215. So then I would be between 92 standard deviations and 2 standard deviations. So my empirical rule says 95%. And then between 140 and 190, I'm 1 standard deviation away. So my empirical rule says 68%. Okay. This is where it can get a little bit tricky. If we look at number 7, it says what percent of weights are between 115 and 165? So I'm looking for, and we can like shade it in, I'm looking for this region here. Well, if you think about it, on this side, I'm 2 standard deviations away from my mean. But I didn't go this way 2 standard deviations. I just did half of it, right? 2 standard deviations would bring me all the way to this side. From here to here is my 95% based off my empirical rule. But I am only doing half of that. So to find that, I'm just going to take my 95 and divide by 2 because I just did half of that graph. So I do 95 divided by 2, and I would get 47.5%. So 47.5% represents that shaded region that we found. Okay. So then if I go, let's look at the next one. So the next one wants to know what percent of weights are between 90, so 90 and 215. So I want this all of this to be shaded. Okay, so here's where it can get kind of tricky in the sense that I'm not the same distance standard deviation-wise away from the mean. On this side, I'm 3 standard deviations from the mean. 1, 2, 3. On this side, I'm only 2. So there are a multitude of ways that you can do this and you can find the area of the shaded region. There's not one right answer. This is just how I do it, and I feel like people find it to make the most sense. So when you're not the same distance from the mean, we're going to go ahead and split this graph in half at the mean. So I'm going to focus on this half of the graph first. On this half of the graph, I'm 3 standard deviations away. So my empirical rule says 99.7, but I'm only looking at half of the graph. So I would take my 99.7 and divide by 2. On this half of the graph, I'm 2 standard deviations away. So I'm going to take my 2 standard deviations, which is my 95%, and again, I'm only looking at half the graph and divide by 2. So now if I calculate these two and I add them together, that would tell me this entire shaded region. So I would do 99.7 divided by 2 plus 95 divided by 2, and that would give me 97.35%. All right, I find that people struggle with this, so let's just do a couple. I'm just going to make a 10 and 11, and I want to find what percent is between 140 and 215, and what percent is between 90 and 190. So we're going to do these together. I just feel like we can use some extra practice. This is kind of, this is different than what we've been working on. So what I'm going to do on my normal curve, so first I'm going to kind of identify where I'm at on my curve. Should really do this on like a whiteboard or something so it's easier to erase. But if I'm between 140, so I'll mark off 140 and 215, I'm looking for this shaded region here. Okay, so you can already tell I'm not the same distance from the mean on both sides. So I'm going to draw my mean. On this side, I'm 1 standard deviation away. On this side, I'm 2. So anytime we're uneven, we're going to look at this half at a time. So I'm going to just cover and look at this half first. So on this half, I'm 1 standard deviation away. So my empirical rule says 68%, but I'm only looking at half of that, right? I'm only looking at 1 standard deviation on one side, not both sides. So I'm going to divide that by 2. Then I'm going to go to this side. On this side, I'm 2 standard deviations away. So I'm going to take my empirical rule of 95, but I'm only looking at half of that. So I'm going to divide by 2. So then if I take those two and add them together, so if I take 68 divided by 2 plus 95 divided by 2. That will give me the full picture that I just drew. So 68 divided by 2 plus 95 divided by 2 would end up giving me 81.5%. And then the next one, if we do between 90 and 190, so again, I'm going to look at kind of what that shaded region is, and then how many standard deviations I am away on each side. So 90 is going to be over here, 190 is right here. So I'm going to get all of this is the shaded region I'm looking for. I'm looking for all the percent, what percent lives in that shaded region. So again, I'm uneven from the mean. If we draw our line at the mean, on this side I'm 3 standard deviations away. On this side I'm 1. So then let's break it down by half. So on this half, I'm 3 standard deviations away. My empirical rule says 99.7, but I'm only looking at half of the picture. So I divide by 2. Then on this side, I'm only 1 standard deviation away. So the empirical rule says 68%, but I'm only looking at half again. So then I'm going to take those two values, 99.7 divided by 2 plus 68 divided by 2, and that will give me that shaded region. And I get 83.85%. Sorry, that looks really ugly. 83.85%. All right, if you're still a little confused, that's okay. We're going to look at this some more over the next couple days. But this was just kind of our introduction into our normal distribution and our percentages. So let's just finish up number 9, and then we will be done with this for today, and we'll look at it again next class. So this asks how many people from the sample weight weigh between 165 and 215. So again, first I need to find what area I'm looking for. So if I'm running out of eraser here from doing this so many times. So I'm looking from 165 to 215. So I'm looking for this area here. And in this one, I'm literally just looking at half, right? I'm 2 standard deviations away from the mean, but only on half of it. I didn't go all the way to the other side. So I'm going to do my empirical rule, which is 95 divided by 2 to represent that shaded region, because I didn't go 2 standard deviations this way. 95% go from here to here. So since I only did half of that, I take my 95 and divide it by 2, and I get 47.5%. But now it's asking how many people from my sample weight. So 47.5% of people. But how many is that? Well, I started with 75 men. So I want to know what 47%, so 47.5% of 75 is. So I would take 75 times 0.475. And I get that it's 35.625. So about 36 of the men, right? That's how many actual people, not percentage, but how many actually people fall within that shaded region that we found. So like I said, this is just an introduction. We'll talk about this more next class, but hopefully you understand at least the percentages of the basic empirical rule as we move on.